Hey everyone. So today we will solve this leet code question, which is container with most water. And what ideally we want to do is, basically between any two heights, you can see that in this case it's this guy 2.8. And if I quickly switch to lasso selection, let me go and select this guy. And if I move it to the pointer where it is, yeah. So these are the two heights between which we have the maximum area, and that is 49. So you can see that I've just written the coordinates so that it becomes more convenient. So this is 9, this is 2. So 9 minus 2, which is 7, and the minimum height is 7. So 7 into 7, 49. Okay. So we will be trying to look into this, and if you see, the basic approach would be, to move pointer by pointer. So for each element, like let's say we start with the first wall or first height, whatever you want to call first. I think wall is better. So for first wall, we can start with the second wall, go to third, fourth, fifth, sixth, and so on, and we compute the area in all those cases, and then we compare that. If it is greater than the maximum area that we earlier assigned to, we can start with 0, and if it is greater than that, then we reassign the area and then move on. Okay, and once we reach the last element, then we again go to the first one, which is this guy, and then move it to the next, and then we bring back our pointer so the screen guy here, just basically if it is I, so I plus 1, and then keep on iterating for all these and do it and until we reach last. That's where we are sorted. Okay, so this is the number one method, and let's start with this. Of course, this is for every single iteration we are reiterating to the n times, n meaning the length of this array. So let's say if these are 10 elements, here it is 9. So for first we are doing 9 iterations, for second we are doing 9 iterations, and so on. Of course, it is reducing for every iteration. So when we reach second, we have less number of iterations. So it gets 9 into 8 into 7, so 9 factorial. But it's still considered as O of n square. Okay, because we are doing, for each iteration we are iterating again and again. Okay, so that is one thing. Now let's start to write some code and see how we can do achieve this, and then we will optimize it further. Okay, so here we are in the terminal. Container with height on square. Let's do like this. We will get the height array and let max area equal to how much? 0 initially, and then we will iterate for let I equal to 0, I less than dot length minus 1, I plus plus y. If you see here, let me go and select the lasso. So if you see this guy, it will reach until this point, and we don't need to, because after this there is no wall, right? So we can do it till I minus 1, and that's why we are doing I minus 1. And similarly for let j equal to I plus 1, j less than I dot length j plus plus, and now we will compute the area. So let's have a function dedicated for that. Get area equal to x1 comma y1 comma x2 comma y2, and it would be math dot absolute of x1 minus x2 star math dot min of y1 comma y. Why I'm saying so? So if you see, let's say 2, 8, and 9, 7. So the area would be length into breadth. Length is x coordinate is 2, y coordinate is 9. So 2 minus 9 or 9 minus 2, we are taking absolute, doesn't matter. So that will give us the breadth. And for the length, we want to pick the minimum height because that would be the maximum capacity of that container, right? So this is 8, this is 7. So math dot min of 7 comma 8, which is 7, and that is why we get the area 7 start 7. So that is what we have written here. Okay. So let's get the area, which is get area function, and then we supply I as x1, height of I as y1, then j as x2, and height of j as y2. Okay, and if area is greater than the max area equal to area. All right, and then we do return this guy. So max area, and let's clear it out, and let's quickly copy paste it to the lead code. And here we will just do a return max area, not max area, container with this most height with O of n square, and we will give in the height. And note that here we are using max area variable here also, but since it is locally scoped, that is the scope of this guy is limited to this function, so they won't interfere. Okay, otherwise we may have to change this variable. But anyways, so let's quickly run this code and let's start it up. So it says time limit exceeded. Of course, that is because you know um, we have O of n square, and which is basically not generally accepted in lead code. So let's see how we can optimize this algorithm. Okay, now watch carefully what I say. Okay, so now understand this very carefully what I'm saying. So what we are planning to do is we are planning to move, as we move closer these pointers, the x distance, which is the width, is always going to decrease. Okay, that is for sure. So if we keep on moving from the minimum side, we will end up in reaching always reaching the maximum area. Why? Let's say this is 1 1, and let's say if I move, because this is minimum, so we with this guy, which is the 9,7 wall, its area would always, as we reduce the width, the only case is that when the length increases, which is the height of this, if the height increases, then only we will encounter. So let's say 1197, the area would be 9 minus 1, which is 8, and the minimum is 1, so 8 units, 8 square units. Okay, now this would only increase if the height goes more than, if the height is less than this guy, it is anyway going to decrease because width is always reducing, right? So using this concept, I hope you got that. Just hear me out again. What I'm saying is that when you are at 1 1 and then you move to 2 8, you know, as long as the height, whenever the height increases, that is the only possibility when the whole area would increase. Because anything that is less than, here its height is 1 unit, anything that is less than 1 unit, it is definitely going to give you lesser area. That is for sure, right? So we are eliminating all those cases, in order to avoid iterating again and again. Did you get that? So because we are sure that width is going to reduce for sure, and if height is also reducing, then definitely we are going to get lower area, not the higher side. And that is why we are moving the pointer from the place, like we're moving from 1 1 to always moving the pointer which has the minimum height out of those two. So in this case, 9 7 and 1 1, of course 1 1 is minimum, so we will move this guy. Okay, and then we will calculate the area and do all those things, like if the area is greater than the maximum area, resubstitute it. And once that is done, now again move the one with the minimum height. So this time I'll move this guy. Again, this is minimum, so I'll move this guy. And now this guy and this guy both are similar. So for equality, we can move anyone. That doesn't matter. Okay. So again, we can move this guy. Now again, this is lower, so we will keep on moving and this will keep on happening and we will reach this point. And when these two are equal, then we will break the loop. Okay. So that is the concept that we are using. And you see that this is just O of n. We are not doing any other kind of iteration. So that's the concept. So let's quickly dive into the code and let's copy paste the same code. And this time it is O of n. So height, let max area equal to 0, let start pointer equal to 0, let end pointer equal to height dot length minus 1. Okay, and instead of for loop, let's have a while loop. So start pointer less than end pointer. Whenever this is happening, we will do const left container height, which is equal to height of start pointer. Similarly, right container height equal to height of end pointer. Area equal to get area start pointer comma left container height comma end pointer comma right container height. Okay, so area greater than max area, then we do max area equal to area, and now we need to move our pointer. If left container height is greater than, sorry, if left container height is less than right container height, so this is the case. If the left container height is less than the right container height, then we want to keep right container at its position and move left container, I mean left pointer. Okay, so we will do left pointer plus plus. Okay, otherwise in other cases we will do right pointer, sorry, end pointer, not left pointer actually, end pointer minus minus. Okay, and then we will return the maximum area. All right, so let's quickly copy this guy and let's go to Leetcode, uh, replace this code with our new snippet, and let's copy this up. All right, so let's quickly run this code. So we get the output as expected. Now let's try to submit it. Yeah, so you can see that this time again this time it is accepted, and it says that it is faster than 11.21% of the JavaScript. Again, this is kind of a variable. So we got our solution accepted this time, and that is what all it was about. So we need to move the pointers accordingly to make this from O n square to O of n. I hope this video was informational for you. I hope you learned something new and it helped you think about this problem in a in a different way. And that's all for this video. And let me know if you have any questions. Thank you very much.